Hello everyone, welcome to another session of software testing course. Excuse me for late, I don't know you have another lecture at this time, and some of my friends attend to the class about 20 minutes ago. I start the lecture from the previous location because in the last lecture you have not the slides and just you have received the voice, and at this weekend I was very busy. Unfortunately, I couldn't take a record and send to you. Excuse me for this matter. And so I have a quick review in this session on those slides. I hope this would be proper for you to learn about these concepts. Yes, you can. You should install, for example, Eclipse Enva IDE for Java programming. If you have experience with Java language, there's no problem. But if you are not familiar with this programming language, you should see some tutorial videos about Java programming in this lectures. We just we will write simple Java programs, and you could got it because the Java syntax is very similar to C++ or other languages syntax. Do you hear me? Do you have sound? Okay. So you can see some tutorial videos from the web about programming in Java. There is no problem because we use some simple methods in Java, as you have seen in previous lectures. And we try to learn you how to write test script in JUnit. There are simple structures in JUnit you can use to writing your test scripts. So let me go to the slides. We have talked about model-driven test design in previous lecture, and you are familiar with this chart as a test design, model-driven test design approach, and we have explained several test activities according to this chart, such as test design activity, test automation, test execution, and test evaluation. As you know, we have 4 general test activity in software testing. We define these activities as you see from this figure. As you know, we should extract some mathematical structures from source code as a model or as a structure, software structure or model structure, and we use some coverage criterion. We use a coverage criterion to extract our test requirements from the model or mathematical structure, and we can add some test requirement via human experts, via human approach test design, and we could have a refinement process to refine the requirement set, test requirement set, and then we should generate some test values or input values for our test cases. Beside of these test values, we should provide some preconditions such as and expected results of a test case for our test cases, and some postfix package that include input values, prefix and postfix and expected result. Altogether we name this package as test case. So if we have some test cases, we could generate some, or we can write some test script to run the test cases and observe the result of the test executions. With this aim, we would explain the JUnit framework for generating test scripts at this lecture and next lectures. After we have generated test scripts, we could run tests or test cases, and we can have test results. And again, by JUnit framework, we could evaluate our test case executions. In test evaluation, we compare test results by expected results. If test result, if actual output is the same with we could say the test passed. But if there are different in this two results, result and actual result, we could say the test was passed, was failed, and we should review our design or our test cases. It's possible that the test case be faulty, or the our design, our software artifact could be faulty. So we should review design and the test case, both the artifact and the test cases. With this chart, we know that our abstraction level, our abstraction in design level could rise the abstraction, could hide a very large set of exists in code, and we can work with some structure, some mathematical view of internal principles of mathematical concepts. We can process these structures, the graphical structures, such as control flow graph, very simpler than analyzing the code, source code of our software artifact. So by this approach, we can rise as you saw. Excuse me, let me see some messages. If any message received, no. Okay. That search the element n in an integer array A. For this aim, in the body of the method, a for loop is used to scan the elements of array 1, compare, and if the n is found, we could return the index of the element, and else we could elements of array until there is another element to compare. Could not form one as the result of the method to imply that there is no occurrences of n in the array set. Okay, for this simple method, we can extract a control flow graph as this flow graph. As you know, this could be done by hand, this could be extracted manually, or this could be extracted automatically via some analyzer tools. In this control flow graph, at first state, we have initialized I be a 0 at this stage. Method, we set I to 0, and we initialize the internal variable I of this Java method to be 0, and in next step we compare I with the size of array, such as this in the control flow graph, and then if we see that I is less than the array size, we go ahead through the body of the for loop, and we can compare the first element of array with n. If these two be the same, we return the I. And in this control flow graph, we pass through this edge, we compare, we execute the if we found the n element, we go to the for state 4 and return the index of n as the first occurrences of n, and else we can return to state 2 and go ahead with next elements of array, and this loop could be continued until there is an element in array, or until we found the element n and go to the state 4. At the end of the scanning the array, if we could not find the element, we can go to the state. We should go to the state 5 and return -1. This is should be very clearly for you, and you have experienced working with this control flow graphs in your compiler course in undergraduate stage. So if we use this structure, this mathematical structure for generating test cases, our works could be very simpler than working with but in mathematical we could use some principles, some solutions for mathematical problems, for mathematical structures, to solve our problems in generating test cases. At this stage we should use a coverage criterion. But which coverage criterion criteria could be used to generating test cases from these mathematical structures? As you know, some test criteria could be node coverage according to this graph, could be edge coverage, edge pair coverage, or path coverage. A path coverage is a sequence of edges that start from initial state and lead to a final state. This could be a execution path. So we could select a coverage criteria from this criterion, from this set of criteria as I mentioned, to generate test cases, and we could generate test requirement according to our mathematical view of internal structure of the source code, and according to our coverage criterion. So for this example, if we use edge coverage as test coverage criterion, we should cover all edges of this control flow graph. All edges of this control flow graph is the edge that connect state 1 to state 2, this edge, and state 2 to state 3, this edge, and so on. All of these edges are listed in this box, and if we use edge coverage criterion, we should generate test passes. We should generate test passes that could cover all of these edges. Probably you know that by a test pass we could not cover all of these edges, because there is a branch, and with an execution pass, with just an execution pass, we could not cover all edges, because each execution pass could lead to one of the final states and not both. So at least we should use 2 execution paths to cover all edges of this control flow graph. For example, the first execution path could be this execution path. Start from state 1 to state 2 to state 3 to state 4. This is the first execution path that cover this edge. This one, and this one. And the second execution path could be this execution path. Start from state 1 to state 2 to state 3 to state 2 again for covering this edge, and then to state 5. So we could cover all these edges by at least 2 execution paths. 2 execution paths. And we should generate input values so that the program behave as we want in our execution passes, according to our execution passes. But with the next coverage criteria, say edge pair coverage criteria, we have a list of 6 edge pairs from this control flow graph that consists of these edge pairs. The first edge pair could be this edge pair, this edge with this edge. Start from 1, then to state 2, then to state 3, the first edge pair. The next edge pair could be this edge pair, this edge and this one. The next edge pair should start from state 2, could be this edge pair and this edge pair, and the next one could start from state 3, this edge pair and this edge pair. Altogether we have 6 edge pairs, as you know from previous lecture. This is the set of all edge pairs could be extracted from this control flow graph. So for covering all of these edge pairs, all of these edge pairs are our test requirements. As you know, we could define our test requirements according to our coverage criterion. If our coverage criterion be edge coverage, we have this set of edges as our test criterion, test requirements. And if we select edge pair coverage as our test criterion, we have this set of edge pairs as our test requirements by this coverage criterion, defined by this coverage criterion. So to cover all of these edge pairs, we should generate some tests, we should design some test passes or some execution passes from this control flow graph to cover all of these edge pairs. So go ahead with this box, the test passes to coverage all of these edge pairs should be at least 3 test passes, because the first test pass is this pass. It starts from state 1 to state 2, then to state 5. Okay, say this test pass. This test pass just cover one edge pair. Say this edge pair. This edge pair is covered by the first test pass. The second test pass, as illustrated in this slide, is the test pass that starts from the initial state 1, then go ahead to state 2, go ahead to state 3, to state 2 again, and then to state 5. This path, this execution path, cover which edge pairs? The first edge pair that is covered by this execution path is this edge pair, this edge and this edge pair. This is the next, this is the first edge pair that is covered by this execution path. And the next one is the edge pair from 2 and go to 3, 2, 2 again. This edge pair is covered by the second execution path again, and the next edge pair coverage, the edge pair that could be covered by this execution path is the edge pair that starts from state 3, go to state 2, and then go to state 5. This edge pair also could be covered by this execution path. But some of our test requirement could not be covered by these two test passes or these two execution passes. So we should introduce another execution path to cover uncovered edge pairs. Which edge pairs are uncovered, remained uncovered? These edge pairs are not covered. The edge pair starts from state 2 to state 3 to state 4. This edge pair is not covered until now. And this edge pair also is not covered. The edge pair that start from state 3 go to state 2 and then go to state 3 again. So this edge pair, the fifth edge pair, and the third edge pair are not covered by the first two execution paths. Okay, so we should introduce another execution path that covered the third and the fifth edge pairs. This edge pair and this edge pair should be covered in the next execution path. So the next execution path should run a loop more than once, run the body of the loop more than once, so that the edge pair from state 3 to state 2 and then to state 3 should be covered. And then the last execution path should be terminated in the fourth state or state 4, because this state, this edge could not be covered by the first two execution passes. The edge pairs that lead to this state are not covered by the first test passes. So we use this execution path to cover the remaining edge pairs. This execution path starts from the initial state 1, go to state 2, to state 3, then to state 2 again, then to state say this execution path. So by the three execution passes, we could cover all of these test requirements, which extracted by edge pair coverage criterion. Okay. So the main problem or the most challenging in generating test cases is find values. We should find values to control the program, control our method, or control our structure so that behave as we want in this execution passes. Which values for this Java method could run according to the first test pass? Which input value is needed? Which input value is needed to behave as this execution pass? This execution pass is start from state 1, then to state 2, then to state 5. By which input values we could run according to this pass? By which input value we could pass these edges? Can you say me? Which inputs is needed for this Java method to pass this execution pass? The simple pass starts from state 1 to state 2, then to state 5. By which inputs we could experience this pass? Can you tell me? Note that we need an input. We need input values that at the first check of the condition, condition of for loop, we should go out from loop, because at the first check we could not go ahead into the body of the loop. If we can go to the body of the loop, or if we can run the if statement, we go this node, this state, but we need an input value. We need input values that don't let to execute the for loop ever. Actually, for executing this pass, we need an empty array. If we feed this method by an empty array, the statements of the for loop never executed. Never execute. Okay. By an empty array, we have array size of 0, and the initial value of the I variable, the counter variable, is not less than the array size, because the array size is 0 by an empty array. Okay, do you got this? So if we have an array, an empty array with some value of n, this is no matter, this is not important. While we have an empty array, the value of n is not important in this case, and n could be any value. For example, let n be 5 and a be an empty array. For this input, when we want to execute this Java method, at the first comparison of I with the array size, we've got that the I is not less than array size, and the body of the loop is never execute. So we should return -1. So this execution path would be experienced by an empty array and any number n. So the first test case for execution, this test path is an empty array with any value for n. The value of n is not important in this case. But in the next execution path, we need another combination of n and a. With this execution path, which start from state 1 to state 2 to state 3 to state 2 again, and then to state 5. According to our Java code, which input values could lead this execution path? Which input values let us to experience this execution path? Start from state 1 to state 2 to state 3, then to state 2, and finally to state 5. Which input values lead to this execution path? Could you tell me? Do you hear me? Do you have sound? You should have a contribution in the class. I expect that you could reply some of my problems. You should answer some of my problems. These problems is very clear and very simple, by which input values we could experience this execution path. Please write to me. At this week, we want to hold our sessions according to our schedule, our official schedule, and please do not set time for another courses at these times at the beginning of the semester, as I don't teach in English ever, and I feel that my speaking would not be bearable for you. I prefer that I take a record for some sessions, some initial sessions. So at this time I feel it would be bearable, my English speaking skill. Do not so bad I feel it's bearable, and you could attend your classes at the formal times. And at this week, in Wednesday session, one of you can have a presentation, could represent your research study for the first time. It would be voluntary, and you can propose voluntarily to represent your research study. Your answer is not correct. You have not noticed my question. My question is that by which input values we can experience this execution path. This simple execution path, as I show in the picture in the control flow graph. The state start to state 1 to state 2 to state 3 to state 2 again, and then to state 5. By which input value we can execute, we could have this execution path. For example, suppose you have an array with just an element, say AB, just an element that is 7, but we want to find the element 5, and AB just A, for example, I write this A be this array and which execution path could we experience? Could be run. Please write in chat box which states could be visited by this. Have you traced programs ever? To solve this question, just a simple programming skills are needed. You have, if you have ever writing simple programs in any language such as Java, such as C++, and so on, you could solve this question. By these input values, we start from state 1, then go to state 2 and compare the size of I with the value of I. The initial value of I is 0. The value of I at this state for the first time is 0. And then when we compare 0 with the array size is 1. The size of array is 1 at least. Then in the state 2 we go to the state 3 to check if n is the same as the only element of array. So in the next step we run the if statement to compare the element of array A with the only element of the array A with n. So we go to state 3, and if we see that we receive that n is not located, there is no occurrences of n in the array, we go to the loop for next comparison. Then we return to state 2 again and compare again. I could be 1, I plus plus, increment the value of I, increments the value of I, and at this stage the I is 1, the value of I is 1, and the array size also is 1, and 1 is not less than array size. So at this stage we should go to the final state 5. Let's say this sequence of states are visited by these input values. Okay, so these input values is proper for the second execution pass. The second execution pass is this pass from state 1 to state 2 to state 3, again to state 2, and then to state 5. By the inputs, as I introduced in the previous slide, we could experience this execution pass. But for the last execution pass, which inputs are needed? Can you solve this question? Which inputs are needed to see this execution pass, the last execution pass, which say the execution pass start from state 1 to state 2 to state 3 and come back to state 2, then to state 3 for the next time, and finally go ahead to state 4. Which inputs are needed? Look at this Java method. This is our Java method, and this is our control flow graph. Which array A and element N are needed to experience this execution pass? This execution pass excuse me. This execution pass. The loop should be run twice. The body of loop should be run twice. By which input values we could experience this execution pass? This execution pass means, note that this execution pass means that the first element of array A is not the same as an element, but the next element, the second element of array, is equal n. This execution path in which we run the loop twice and then go to the final state 4, which say that the element n is found and the index is I. The index of the element n is returned by this statement. So in this execution path, the element that I search it should be located in the second position of our array, because the loop is run for twice. The comparison is, statement if is run twice, and in the second execution of the if statement, we have noticed that n is located in the second position. The index of second position of array is 1. We start from position 0 and then go ahead by position 1. So it's enough to have an array such as this, or we could add some other elements such as 3, such as 8, and so on. So for execution of this test path, the mentioned test path, we need input such as this. The array be an integer array which is in which the first occurrences of n could be happens in the second position, because we want in the second comparison, second execution of if statement, the element is be found and go to the 4. N is that element we search in the array. As I told you at the first, this method, the index of method, search the element n in array A, and if n is found in the array, its index should be returned by this statement. Okay. Let me go to the next slides. So we summarize this subject at this stage for excuse me, in a model-driven test design, and in test design stage, we should use a coverage criterion to generate our test requirements from a model or structure of internal code, of internal structures of code, a mathematical view of internal structures of code should be extracted first, and then by using a coverage criterion we should generate our test requirements and then refine this requirement set, and then we should define a process to generate input values. In this process, what we do is that I explained for you. For this matter, we generate a control flow graph. For example, a control flow graph from code structure, and then we use some coverage criteria such as edge coverage and edge pair coverage to generate our test requirements in each test criterion. For example, for covering these test requirements, we should experience these execution passes, and the next problem is to find some input values to control the behavior of program according to these execution passes. Okay, and this final challenging problem remains at this stage, and I will explain some approaches to find input values at next. But in this simple case, we explained for you how to generate manually input values for each of these execution passes at this lecture. So at the final slide stated that most of this book, Introduction to Software Testing by Paul Amman and Jeff Offutt, is our textbook, and most of this book is about test design and other activities such as test automation, test execution, and test evaluation are covered elsewhere. Also, this is told at this last slide, but the next chapter, the chapter 3, are well suited to explain how to use JUnit framework. How to use JUnit framework for generating test scripts to test Java programs. So let me go ahead through these slides of this chapter 3 to introduce the primary concepts of JUnit. Before we explain JUnit for you, we explain some preliminary and concepts of using JUnit. As you know, I have introduced you a YouTube video that explains how to use JUnit framework to testing Java programs. If you have not seen this video, please see as soon as possible, and in the next session we should be familiar with Eclipse IDE environment, and we should be familiar with JUnit environment, and I explain it as possible for me, but I prefer you learn from some suitable videos from web, because they explain very fluently, very by native speakers, by native lecturers, and you could notice better from that videos when I explained the JUnit for you. It would be clear for you, and you have no problem with me. If you have any question, you could ask your question before I start. the next chapter. Who is ready to represent your study project, your research paper? Who is ready for Wednesday session? As I remember, I answered all of the messages that sent to my private, but some of your messages that you have sent from the group, I see some of them that repeated, and I answered from my private, but if you have not sent for my private, excuse me, and please send again to check and answer you. Please send again. Most of your topics are set and you have no problem. Some of you sent me your presentation slides, and we want to start at the next session to represent your study research. The first people could have more grade, and we consider the first person difficulty, and we consider his presentation with more grade. Depends on your lecture, that depends on your problem. You can speaking for 30 minutes, but it's possible to for your friends to ask her questions or his questions, and probably I have some questions. I explain some skills in presentations of research papers, some of your slides, your representations slide that were sent for me have some problems, some fundamental problems, and I would explain according your presentations in first sessions of your presentations, and I hope for the next ones there are no problems in your slides and your representation. So if the first person introduce himself to me for this Wednesday, I appreciate this happening, and I would consider some grades more than others. Some of you sent some messages that to record your video about your presentation. This could be done very limited. Just 2 or 3 of you can record this as they mention their problems in speaking English or some other problems. If you have no problem in speaking English, it's better to represent your work at class, and I negotiate with you about your research paper, and this is very, very important in your learning. So for about 3 or 4 persons for all of you. Okay. I guess you are tired because you have another lecture before this class, and it's very late. Take the next chapter. Let me to postpone this chapter to the next session. If you want to present her work or his work in the next session, please notice me via my private. So you have a nice day, and see you soon. If no question, let me terminate the session. Let me finish the session. Thank you. Goodbye.